Hi, Ross. So you have this probability question, right? So it says that 20 families consisting of a father, mother, son, and daughter are on a treasure chase or something to that effect, right? And there are groups of two, right, that can be selected to win. So we need the probability that it's going to be a mother, but not her daughter. Okay. So to sort of see what's going on, always draw out a sample space like I did here, right? So we have 20 families, right? We have a father, mother, son, daughter, right? So I put subscripts one of each of those, right? The second family we have two, 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 so on and so forth, all the way up to 20. So we need the probability that is the mother and not her daughter. So let's set up the denominator. So right there are 80 um elements, I guess that's the word to use. And we're gonna select two, right? So it's gonna be 80 chooses two. So I'm gonna put that in the denominator. So hopefully you see where this comes from. Right? It's a combination, not a permutation, because the order does not matter. So the big question is, what am I gonna put for the numerator? So let's see if we can generate some kind of pattern, right? So we have, right, this mother can go with the father, it can go with the son, but not the daughter, right? This mother can go with this daughter or say this daughter, right? D2 or D3, but it can't go with D1. So let's count it. So we have one, two, right? So that's two plus five, six, seven, eight, 9, 10, 11, 12, right? So 4 times 19, right here to here is 19. Be careful, it's not 18, right? For instance, 2 and 3, that's 2, right? 3 minus 2 is 1, but it's 2. So 2 to 20, that's actually 19. So I'm going to say 2 plus 19 times 4, right? Which is 78, right? So it has to include a mother. So right now I'm looking at this M1. It has to include a mother, but not the daughter, right? So we have 1, 2, right? 3, 4, 5, 6, 7, 8, 9, 10, right? So it's going to be 78. Now let's look at this mother, right? So again, 1, 2, right? This mother cannot go with this daughter, but it could go with this daughter. So 1, 2, 3, 4, 5. I'm not going to include this M1 because it was already counted, right? So 1, 2, 3, 4, 5. So it looks like 5 plus, so this time there are 18. So 18 times 4, right? So that's going to be 77. So that's just looking at this mother right here, the second mother, right? So plus 77. Let's get M3 and M4 to see if we can find a pattern. So with this mother, right? 1, 2, 3, 4, 5, 6, 7, 8. So again, right, we already counted M2 and M1, so that's why I skipped those. So it's going to be 8 plus, now let's look over here, right? So there are 17 of them now, right? 20 minus 4 plus 1, so that's 17 times 4, 68 and 8, that's going to be 76. So I'm going to put plus 76. So I'm just going to do 4, then we're going to come up with a conjecture. So if you look at the fourth one, right? 1, 2, right? I'm skipping this one, and I'm skipping all of these mothers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, so that's 11 plus 16 times 4, which gives 75. So our numerator is going to decrease. So for the sake of space, I'm not going to write 75, right? So it's 78, 77, 76, 75. So the question is when we hit 20, so the 20th number in our numerator is going to be what? Well, this is arithmetic. Or better yet, instead of making an arithmetic sequence, let's just subtract 20 and add 1 to it. Right, so 78 minus 20, that's 58. If I add 1, it's going to be 59. So when we get to this mother, we're going to count 59 possibilities. All right, so we're going to end up with this answer. So let's clean this up a little bit. So that's the answer, but let's so it's arithmetic, right? So you have 59. I'm going to put the smaller number first. Plus 60 plus 61 plus dot plus 78. Now remember, for an arithmetic series, I don't know if you covered this, it's going to be n over 2 times a quantity, our first term, right, a of 1 plus the last term, a of n. So there are 20 numbers, right? 20 divided by 2, that's 10. So I'm going to say n is 20. A of 1, that's 59. And the last number was 78. Actually, the first number was 70, the last was 59, but A plus B is B plus A, so it doesn't matter. So 137 times 10, that's 1370 in the numerator. All right, what about the denominator? So go back, right? We had 80 chooses 2, so you know the combination formula. I don't know if you covered that, but that's what we have to use. So 80 factorial over 2 factorial, that's just 2 times 80 minus 78 factorial. I'm sorry, this should be 78. So let's see, 80 times 79 times 78 times 77 times blah, 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 blah. 78, so it's going to be 80 times 79, right? Because 78, 76 is going to cancel out with the 78 factorial. I'm going to divide this by 2, right? 80 divided by 2, that's 40. 79 times 40, that is 3,160. So 3,160. And from the looks of it, I could just kill these zeros. So I would say the answer is this. So I hope this helps. Again, you can, in the comments, you can tell me if I'm right or wrong, but I feel pretty good about this. Have a good one.